So what we're going to do today is we're going to talk more on function notation and solving and writing the function rule using graphs. Okay, so um, I have another example for you. It says to make money, the soccer team plans a special project to take orders for roses and deliver them on Valentine's Day. That's really sweet. The team found two shops. Roses Are Red and Flower Power. For roses are red, it costs $20 for the service charge plus 75 cents for each rose. So if you remember a couple days ago, we talked about the service fee, the one-time fee. That's $20 for roses are red. Then for every additional flower you buy, it's 75 cents. And then for Flower Power, it sells roses for a service charge of $60 plus 50 cents per rose. Okay, so here's a little animation, not that, sorry. Here's a little animation to kind of see the pricing. Okay, so here it says for roses are red, the cost for one rose would be $20.75. Two roses would be $21.50, and three roses would be $22.25. Okay, so notice how it kind of magically put all three of those together. We multiplied by 3, and that's what we got. So we could say our service charge is $20. Plus we had one rose for 75, one rose for 75, and another rose for 75, which our whole cost would have been $22.25. Okay, well, let's see for Flower Power what happens now. So here's the same kind of image for our Flower Power. So ooh, look, they added a ribbon, but these are cheaper. So for 2, it's 61, and for 3 roses, it costs $61.50. Okay, so clearly Flower Power is a little bit more expensive because that initial fee is $60. Roses may be cheaper, but your setup fee is a lot more money, so this was $61.50. Okay, all of these blanks are going to be in the animation that I show you next. So it says, now that we've explored the offers from both of those, let's solve the puzzle. It says the blank of the roses depends on the blank of the roses in the order. So we would say the total cost, so that's your first blank, of the roses depends on the number of roses in the order. Each number of roses gives a unique cost because each different number of roses gives a different cost. In other words, the cost of the roses is a function of the number of roses because the number of roses is what's going to make that total cost change. So the number is the independent variable and the cost of the roses is the dependent variable. Okay, so all of those squares are blanks in your notes. It says you used repeated addition to calculate the cost for a small number of roses from each shop. However, repeated addition can be slow and not practical if you're trying to calculate costs for large number of roses. Fortunately, there's another way. So instead of repeated addition, you can use multiplication. So I'm not going to make you do for roses are red, 75 cents with 75 cents with 75 cents. We know that there's a $25 or $20 setup fee. And on top of that, it's 75 cents per rose. In this one, you're now buying 12 roses. So if you do 0.75 times 12 plus your $20 setup fee, to buy a dozen roses, it would cost $29. If we did the same for 24, okay, we would do 20 plus 0.75 times 12, or I'm sorry, 24, you would get $38. Okay, same for 36. So we would say 20 plus 0.75 times 36. We would get $47. Okay. So what I want to do is let's just pick a few other numbers. Let's do 48, and let's say they get a really big order of 100, and then I'm just going to put n for the number of roses. So here we would say 20 plus 0.75 times 48. and 20 plus 0.75 times 100. So take a second and solve that. You should get 56 here, and you should get $95 to buy 100 roses. So N is going to be part of our function rule. N is the number of flowers that they bought, and it's going to give you your total cost. So what changes in these three columns? The number of roses, the cost, and that's really it. What stays the same is that $20 fee, right? Because that's the one-time fee that you're going to have no matter what. Using the function rule, this is our function rule right here, what would the cost of 30 roses be? So if we said 20 plus 0.75 times 30, you would have, sorry, I'm doing my calculations, it would cost you $42.50. Now the question is, how many roses can you get for $100? So that's the total cost. So we're going to put that into C and set it equal to our formula. So we would subtract 20, and then you would get 80 is equal to 0.75n divided by 0.75. So we would do 80 divided by 0.75. And you'd get 106.67. Now, can you have this? It's an actual item. Well, unless you want a broken rose, no. So we're going to just round up to 107 roses for $100. Now let's talk about flower power. So we used 4800 and N on our last one, so I'm going to do that here. Okay, and then for flower power, it was a $60 setup charge, but it was 50 cents per rose. Okay, so let's fill out our process column. Filling in next to the 50 cents in our parentheses is the number of roses that we were given. Okay, and then once we have that filled out, I want you to pause the screen, and I want you to figure out the total cost of the roses. So you'd fill out that side. So as soon as we get this filled out, I'm going to pause so I can do it as well. And I'm going to wait on the end. So here's what we have. Notice how these numbers don't climb as fast as the other ones because they're not as expensive. The only reason they started so high was because you had a higher starting amount. So if we used N, our function rule would be 60 plus 0.5 N because it's 50 cents per rose plus the $60 setup charge, and that's going to give us our total cost. So using that function rule, how much would 30 roses cost? So we would again put 30 in for N, and I already have it figured out, and that's going to be $75. But how many roses can you get for $100? Well, we know it's not 100. So it would be 60 plus 0.5 N, subtract 60. So you have 40 is equal to 0.50 N. When you divide by 0.50, you have 40 divided by that, and you can buy 80 roses. Now, if you look up here, you can get 107 roses at the other place for the same amount that you would get 80. So I think we would choose the other one if we're not ordering a lot. So here's another situation. Okay, it says a small office wants to order new light bulbs for their lamps. Bright Lights charges $32 for every bulb they sell and nothing for shipping. So you get free shipping. Lights for Less charges $24 for every bulb plus $52 for shipping. Fill in the table and write two function rules to model the situation. Okay, so if we were to order 0 for Bright Lights, okay, Bright Lights, remember, is $32 per bulb, but there's no shipping, so it's plus nothing, right? We don't need anything else. So really, if you don't buy anything, you don't pay anything. If we bought 1, we would pay $32. If we bought 2, we would buy 64 or pay $64. Okay, I know there's some more, but I'm just going to move on to this other side so we know what we're doing. The Lights for Less, it's $24 a bulb, but you have to pay $52 for shipping to ship however many you bought. Okay, so even though you don't buy anything, you're still paying $52 for shipping. Okay, if you were to buy one bulb, you would have 24 times 1 plus your $52 for shipping. So really lights for less is a lot more expensive. And then if you were to buy 2 bulbs, you would have to pay $100. Okay, so I want you to continue this pattern all the way down, 3, 4, 5, and then we're going to say N for the number of bulbs. So again, I'm going to pause the screen and I want you to fill out the rest, and then we'll go from there. So if you notice, what we have is we filled out the rest of the table all the way up to 5. And then the bright lights is $160 for 5, and lights for less is $172 for 5. So I have a feeling the next one that comes up, lights for less is suddenly going to be cheaper. So our function rule for bright lights would be our total cost is equal to our $32 per light. Okay, because remember there was no shipping. And then the function rules for light for less would be our total cost is $24 per light plus $52 in shipping. And that's that one-time fee. You don't pay $52 per light. It's all of them together. If you wanted to buy 10 bulbs, how much or which one would you go with? So we don't know the cost, but we know we want to buy 10. So if we substitute 10 in for N, we would say 32 times 10 is $320. They must be LED or something. I don't know. 24 times 10 is $240 plus $52, which gives you $292. So really, lights for less is cheaper when you buy bulk, so more. There is another problem. I'm running out of time on my screen. So, but if I could help you, your sister has a savings account of $825 and plan to save $20 a week. The function rule for your sister would be savings is equal to, what does she save? $25 a week plus her initial amount she put in there. And your brother, his function rule would be his savings is $10 a week plus his initial $1,050. Let me try that again. $1,050. Okay, so if you want to fill out that table, that's fine. You should have gone over it in class. Again, I'm running out of time on my video, so good luck with this. It is another day of review, so we're gonna move on Monday. See you later. I lied. You didn't see this in class because I'm not here. Silly me. Baby brain. One thing real quick, I know I have like a minute left, but one thing you're going to see in your homework is you're going to see these box problems. They look something like this. So what it's going to do is I'm going to give you 2 numbers somewhere in these boxes. Okay, so let's say I gave you 5 and 10. What you have to do with them is you have to multiply them. So you would get 50 here up on top, and then you would add the 2 side numbers to get 15 on the bottom. Now, I'm not always going to give them to you like that. Sometimes I may give you this one here, like let's say I give you 20 and then I give you a side number 7. So we added 20. We did 7 plus some number is 20, and then you had to multiply to the top. So 7 plus what will give you 20? If you said 13, you're correct. And then you multiply them together, and 91 would be the top number. So you are going to see this in your homework tonight. So just, I wanted to throw that in there. I apologize. I think I have baby brain. And everything else on your homework you should be able to do. So even skipping this one problem. So have a great weekend.